Hey everyone, and welcome to The Explainer. If you're deep in the trenches studying for your architect registration exams, especially PPD and PDD, you are in exactly the right place. Today, we're going to break down one of the most critical concepts you'll need to master, the Rainscreen system.
So, let me start by asking you something that might sound a little crazy. What if a wall's greatest strength wasn't keeping water out, but actually letting it in? I know, it sounds completely backward, right? But embracing that one simple idea is the absolute genius behind the modern Rainscreen system.
But, before we can really appreciate the solution, we got to understand the problem. And that problem begins with this idea that sounds great in theory, but is a total disaster in practice: the myth of the perfect wall.
For years and years, the thinking was pretty straightforward. Just build a perfect barrier, a single, solid, completely sealed layer. The goal was to wrap the building in a perfect raincoat, thinking, hey, if we make the outside absolutely waterproof, nothing can possibly get in. Simple enough.
But here's the thing. In the real world, that's just a total fantasy. Materials expand, they contract. Sealants get old, they crack, and they fail. And let's be honest, construction is never 100% perfect. Plus, you have powerful wind pressure that will force water through the tiniest little crack. So when that perfect seal inevitably fails, and it will, water gets in, it gets trapped, and that's when the nightmare scenario begins: rot, mold, and really catastrophic damage.
So, faced with this problem, architects and building scientists had to come up with something smarter. Instead of fighting this losing battle against Mother Nature, they designed a system that actually works with it. And that, my friends, is the Rainscreen philosophy.
And here it is, the core definition you absolutely have to burn into your brain for the exam. A Rainscreen system starts with the assumption that water will get past that outer layer. So its job isn't to be a perfect barrier. Its job is to be a brilliant manager. It's a total mindset shift from water blocking to water management.
This comparison right here is everything. Just look at the failure modes. A barrier wall is brittle. One little crack can lead to a massive failure. A Rainscreen, on the other hand, is resilient. It's built from day one to handle moisture, which makes it fundamentally stronger and more durable in the long run.
Okay, so that's the big idea, but how does this philosophy actually work in the real world? Let's peel back the layers and take a look at the key players involved, starting from the outside and working our way in.
There are really 4 key players on the team. On the outside, you've got your cladding. This is your first line of defense, the screen that deflects most of the rain. Right behind that, you have the air cavity, and I'm telling you, this is the real MVP, the unsung hero of the whole system. Then comes the water-resistive barrier, the WRB. This is your building's actual raincoat. And all of these layers work together to protect the most important thing, the building structure.
That little air cavity makes 3 amazing things happen. First, drainage. Simple gravity pulls any water that gets past the cladding straight down and out. Second, drying. Air is always moving in that cavity, which helps evaporate any leftover moisture. And third, pressure equalization. Now this one sounds complicated, but it's genius. That air gap allows the pressure inside the wall to equal the pressure outside, which literally stops wind from sucking water into the building. It's pretty incredible.
Okay, this next point is huge, and it's a super common mistake people make on the ARE. Rainscreen is not a thing you buy off a shelf. It's not a material. It's a design methodology. It's a system. And you can create a Rainscreen with all sorts of different materials. So look, you can see everything from classic brick veneer to fiber cement to sleek metal panels. They can all be part of a Rainscreen. What really matters isn't the material itself, it's that middle column, the condition. You always have to ask, is there an air gap? And is there a clear path for water to get out and for air to get in? If the answer is yes, then you've got yourself a Rainscreen.
All right, pop quiz. This is one of the most classic exam traps, so listen up. You see brick veneer wall on a test question, you automatically think Rainscreen, don't you? Well, not so fast. The answer is, it all comes down to the details. A brick wall only functions as a proper Rainscreen if those details are executed perfectly. It needs that continuous air cavity, it needs proper flashing at the base, and it needs clean, open weep holes for water to escape. The second that cavity gets filled with sloppy mortar droppings from the masons, it's game over. It's no longer a Rainscreen. It's just a leaky brick wall waiting to cause you a huge headache.
Now, for panel systems, you've also got a couple of choices for the joints. You can go with an open joint system. This gives you amazing ventilation, and you never have to worry about maintaining sealant. The catch? Your WRB behind it is a bit more exposed, so it has to be really tough and UV stable. The other option is a closed joint system. which uses sealants. This blocks most water at the face, but now you've just added a long-term maintenance task. It's a classic trade-off.
All right, let's talk about the elephant in the room. Money, right? Every client, every project manager is going to ask, is this fancy system going to cost me a fortune? It really all depends on how you frame the discussion. It's not about short-term cost, it's about long-term value.
And this chart tells the whole story. So yeah, that initial price tag for a Rainscreen system can be a little higher. You've got more components, a bit more labor, but look at the long game. The life cycle cost is way, way lower. It's the perfect example of investing a little more upfront to avoid paying an absolute fortune in repairs down the road.
This sentence right here, this is your golden ticket. You need to memorize this. This is your answer for the exam, and it's how you explain the value to a client. You're not just selling them a wall, you're selling them durability, risk management, and peace of mind for decades.
Okay, deep breath. We have gone through a ton of info, so let's lock it all in and boil it down to the absolute must-know facts for your exam. This is your ultimate Rainscreen cheat sheet.
Let's hit these fast. 1. It's a system that does 3 things: drain, dry, and control pressure. 2. The air cavity is non-negotiable. No gap, no rain screen, period. 3. The cladding is just a screen. The WRB is the real waterproof layer. 4. Don't fall for the brick veneer trap. It only counts if it has a clean cavity and open weeps. And 5. On the exam, when you see keywords like durability, moisture management, or long-term, your brain should immediately scream Rainscreen.
And we're going to leave you with this final thought. This shift in thinking is about so much more than a technical detail. It's about creating buildings that aren't just static fortresses, but are dynamic, resilient systems that work with nature. So the next time you're at the drawing board, don't just ask if the wall is sealed. Ask yourself, how does it breathe? Because that is the secret to designing a building that will truly last.